So we are looking at the distinction between x square and 2x. This assumes that you have already done the dot sheets in which you have taken different values for x. So I say x equal to 3 and then I have a dot sheet and then I draw x equal to 3 and 2x is another 3. You've done these, and then x square you would have done as those. That this is an x square, and you've looked at these distinctions and still there is some doubt. So let's see if there's any other way of doing it. In the algebraic tiles, do the same x as x times 1 and x square as a square of x. So let's just see if we can explain that with stories, right? And so the stories we started off with x is that you have a box and the box has some number of material, which is what we looked at before, right? So it has some material. I don't know how many. And then we had different games based on that, 2 boxes like that and so on and so forth. So I have basically some number of tokens in it, I don't know how many, right? And so when we say 2x, we mean there are 2 boxes with some number of tokens in it, right? So in this case, let's take an example. That's 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Yeah. So basically there are 2 boxes with some number of tokens in it. In this case, that some number, which is x, happens to be 7. So 2 of such boxes basically gives you 14 tokens. If x is 7, of course, that's important, right? So this is the story of 2x. Which is 2 such boxes. Yeah. So in this specific case, when x is equal to 7, so x is a variable number, but at any point it can only take one number. So let's take at this point x is 7, right? To show the distinction. So the question for x square is, I have a box and I have some number of tokens in it. And I have as many boxes as tokens. So I have as many boxes as I have tokens. Okay, so someone gave me tokens in a box, I don't know how many, but they said you have as many boxes as you have tokens. So that means I have boxes as I have tokens, and each of those boxes of course has 7. Yeah, so of course, so these two are very different, you can see that. This is 7 plus 7, this is 7 times 7. So it's the same difference as the difference between, so this is an x square, right? So you can say, hey, but why don't I just count the number of boxes and I'll know the number of tokens? That's as good as saying, why don't you open the box, you'll know the number of tokens. So you don't know that it's 7. If it is 7, this is what it will look like. It may have been 9, then there may be 9 boxes. It means you can't see the boxes either in this case, right? In this case, there must be like a bigger box. Which has some number of boxes in it, and as many number of boxes, that many number of tokens, but you can't see any of this. They're just telling you some total or something about it, based off which you may be trying to evaluate what it means. So one of the concerns is that this feels fake. This whole situation feels fake, and it feels like, wait, this is never going to happen, right? So mathematics is used to model life, one of the things that it is used for. So let's take an example. You have a ball and a ball is falling to the ground. Okay, and we are basically thinking about how much distance it travels in some time. It can be from very tall height and so on. So what you do is you measure the time, right? So it turns out that as the ball is falling, the speed of the ball is changing. The ball starts falling faster and faster. Think about it. I am in the first floor, I drop a ball, it hits my head. Okay, that doesn't feel so bad. Now I'm in the second floor and I drop the ball. When it hits my head, it feels harder. And if it keeps falling higher and higher and higher, by the 10th floor, if it hits my head, I am dead. Why is that? If it's only a matter of distance, that would not be the case. The fact is the ball is getting faster. We know that, right? So the ball is getting faster, and we know that distance is speed times time. But the speed itself is now a function of time. The longer it has been falling, the faster it has been getting. So that same distance is somewhat proportional to something, we call it acceleration, which is itself, so speed itself is changing with time, and that has to be multiplied by time to get a distance. So you get a t square term. So you do get quadratic terms in even everyday experience, and you need to know enough mathematics to be able to model the world.